Doctor, let's just wait for 6:02 we can start. I'm already recording the session.
Sure. Thank you so much, Mr.
Doctor, we can start the session now.
All right. Welcome to this Investing in Our Community new workshop about the smart palm tree harvesting with deep learning enabled autonomous systems. I'm Professor Jawad Yusuf from the Electrical Computer and Biomedical Engineering Department. So basically, the palm trees are basically used for the harvesting of dates, and dates is one of the most commonly used fruits in the Arab region. So there are conventional methods which are being employed for the harvesting, but those methods are labor intensive and laborious. So that's why we are actually working on developing of an autonomous systems that can be used for the regular uh, observations of the health of the dates, and we can also make smart, informed decision making for the harvesting of different types of dates. So for today's workshop, we will go through the couple of steps. So first will be about the general introduction about the problem statement and motivations. And then I will talk about the system which we are actually working on here. And we have developed and we did analysis of the complete system in the various experimental settings. And further, we will discuss about the results. So talking about the problem. So we know that, as I mentioned earlier, date is one of the most commonly used fruit in our world, in the Middle East, and also like this is being exported to the rest of the world. And if you talk about the United Arab Emirates, so it is considered as one of the largest date producers in the Middle East. And currently we have around 40 million palm trees. So the important thing is when we talk about dates, there are variety of dates. And the harvesting of each date type differs. For example, we can see in the market that some of the dates we used in basically kind of immature form with the yellowish color, and some are used in more brownish color. And that's why it is very important that we have very experienced farmer, okay, that can decide in the farm that what is the harvesting condition, that is this date has reached its desired maturity stage so that the bunch, the dates can be plucked from the actual palm tree. Because if it is not done at the right time, then the ripeness level can increase, and that can basically may damage the fruit quality, and it eventually results in more wastage of the fruits. So, but with the passage of time, what is happening? we are actually lacking more and more of these experienced farmers, because we have let's say one farm contains 10 different types of dates. So each date type maturity stage differs. So its harvesting condition differs. So a very experienced farmer is needed to make a decision by just looking at the naked eye. Like, this is my tree, look at the naked eye on the bunch and then decide, okay, this is not in the good condition, let's move to the next tree. Okay, this is a tree which I need to harvest. Then the next mechanism start, the labor will come, okay, they will uh, go like they can use the machinery, or sometime the labor just like went up to the tree and just like do the buckling of the actual the prepared bunch, and then the next thing started. But this whole process is very labor intensive and and very inefficient. And above that, these practices also basically make many environmental issues. For example, deforestation, biodiversity loss, and because of this, more and more impact is going on with the greenhouse gases, which is not sustainable practices. So that's why we are working here for the designing of an autonomous monitoring system that can basically help us to monitor the harvesting condition of different type of dates. Also, it will help us to differentiate the date type. Like, I have 10 different date types. Okay, so I would have that much experience to tell me, okay, this is, for example, the Barhi, this is, for example, the date type 2, date type 3, and date type 3 has this maturity stage. So all these things can be done using this autonomous system. So the motivation behind this project is that we use the advanced robotics, AI and machine learning technologies that can help us, okay, that the autonomous robot that just go on the walk in the palm tree, palm, or like wherever, like in the, for example, a park, we have different palm trees. So the robot will go on the walk, it will capture the images of the date bunches, and then it will decide autonomously itself, okay, this is date type 1, this is date type 2, this is the harvesting condition. And then it will create a report that will help the farmer or like the manager of that farm, and he can make informed decision making just by looking at the report. No need to send a person. And particularly, this will be very important, and it has a lot of advantages to work with such autonomous system in the hazardous or like very intensive environment of the Middle East, for example, the UAE. So other than that, this will also help us to reduce environmental impact. Okay, because we are applying the very optimized harvesting technologies and algorithms based on the real-time data. So everything eventually we are going to solve the issues of the environmental. And plus, not only this, our proposed solution is basically fully supporting the sustainable development goals, particularly the goal 2 for the zero hunger, responsible for the consumption and production, 13, climate action. Like, with the reduction of the deforestation and biodiversity, we are eventually contributing towards the climate action. And lastly, life on land. So with the sustainable managing the forest, okay, we are controlling the overall greenhouse impact and everything, and that will improve the life on land. So this is our proposed system, which we have actually developed, and we are implemented it, and we have tested it in different environments. So the idea is like we have an autonomous, like we have designed a robot that have a special kind of a tank tire, so that can help us to operate in the uneven terrain of a real farm. So we know that if we talk about actual date farm, okay, the terrain is not like kind of a smooth. Okay, so the normal robot, it could have a lot of problem there. So that's why like we have designed this using the tank kind of a vehicles, the tires here. And plus we installed multiple sensors, visual sensors, and then we have the ROS and the other sensors. So the primary role of, there are two main visual sensors. One is on the top and one is on the front of. So this top camera is basically used to capture the date bunches. First of all, like this will go on the road, like on the train, and it will try to detect the bunch. And once the bunch is detected, it will take the image of that. And then that image, using the Raspberry Pi based processing system, it will send to the Firebase and receive that our processing unit of MATLAB. This front camera of the robot, this is used to localize a tree, because the system does not only want to just take the picture of the date bunches, and then make the decision based on that. We also want to know like this date bunch belongs to which tree. So for example, so what we have done, we have designed basically QR based code detection system. So every tree has been basically assigned a QR code. So this front camera goes to the tree, read that code. So once, for example, the tree one code is read, so it means its localization is done that this is tree one. Now the top camera will operate, and after the localization, will take the picture of the date bunch. So for the actual pathfinding and autonomous navigation, we are going to basically apply the canny edge detection method. So how this method work? So the front camera, basically there's a AVR camera. It's going to take the images, and these images basically are converted to the grayscale. And after the edge segmentation and hook transformations, that actually help us to follow a path. That this is a path. On the side of this path, I have many trees. So the robot will autonomously moves there, complete a round of the whole farm, and take all the images. So date punch detection. Okay, for this we apply the state-of-the-art YOLO version 8 algorithm. So this algorithm help us to not only localize the date punch, but also like take the clear picture of that. So this path, like this part of the system, is about the basically localization and capturing of the date bunches in the real-time environment. So once we have the captured images, then we are going to apply different deep learning neural networks. So in our case, we have used basically 5 different types of dates: Barhi, Khalas, Manif, Nabu Saf, and Suluch. And also, like these dates, each date has 5 or 6 different maturity stages. So our system using the deep learning neural networks, okay, will first of all classify the date type, that this bunch belongs to which date type. Is it Khalas? Is it Manif? Is it Barhi? And then after that, the system will also classify that which is the maturity stage of this bunch. For example, tree 1, this is Barhi and this is Khalas. Tree 2, this is Manif, this is Pritamar. Why? Because like many dates are harvesting in different maturity stages. So we can make an informed decision. Okay, go to tree 1. Okay, harvest. Okay, take the bunch down. Go to tree 2. No. 3. Yes. So all these things will be done using our front-end user interface. So this front-end user interface will help us to take each bunch and do the classification task, and also can help us to make the informed reports that can help us for the further processing. So first thing is very important in the process is the localization of the date tree. So as in the right side of this picture, you can see that this is the actual setup in the park. So we have a palm tree and we have a different date bunches. So that the front camera, the AVR camera. So like we can see here on the path, we have assigned the barcodes for each one. So this first barcode is basically the start barcode, just to tell the Raspberry Pi processing unit that start the processing of lane finding. So once like this barcode is read, the robot will start its movement, and it will try to follow this lane following, okay, using the cane edge detection method. And next we will have the, for example, the first T1 QR code, tree 1 QR code. It will scan that. Once the scanning is done, okay, so this is tree 1. Then the top camera will work and it will take the localize and take the picture of bunches, and this process will keep moving. And in the end, we have the finished QR code. So this will indicate that the rover has completed its complete one movement of the complete form. And now the system, all the captured images, it will be transferred to the Firebase, and from where we can take the basically MATLAB-based processing. And the biggest hurdle in the autonomous navigation is that how the robot keep within in the basically the lane following track. So for this is a couple of step procedures. So first of all, the taken image, okay, it will be converted to the grayscale, okay, and then we applied basically the canny edge detection method so that we can detect the edges. Like this is the lane of the edges, and I have to move within this. And then based on that, we use the hook transformation that basically for the board, okay, in the software, the program, different like this green and red line, these will be formed, and the robot will move within this. Now, for example, the robot moves here. Now it needs to move here just to keep in the track. So to control the movement of the robot, we actually use a PID controller, and that can actually set the motors to ensure that the robot is moving within the specified lanes for the autonomous navigation. For the date punch detection and localization, okay, the top camera operates, it takes the image, and once the image is taken, it will go through the YOLO version 8 algorithm. So the algorithm is trained on the variety of date punches. So this YOLO version 8 basically has different kind of convolution and max pool layers. Okay, and eventually at the end, in the input image, and finally the object, actually the date punch here, it will be detected and localized. For example, here we can see that this is the date bunch. This is basically detected with a 91% accuracy, 91% probability. And eventually, like if it is moving, it will also track that. Okay, so that like this image is not going beyond. So once like this date bunch detection is done and it is tracked, an image will be taken and that will be forward to the next processing unit. This is just some results of our trained YOLO version 8 model. So we use basically around 300 images of different date bunches. And after the label using robot flow, okay, we did the training. The data set was divided into training, validation, and test. And here we can see the results that the training loss is becoming smaller and smaller, which actually indicate good training and the learning of the our YOLO version 8 program. And we got basically with our trained model, the precision of 96.9%, which is actually indicate that the model is has learned very well, and it can classify and track the images, okay, as per the requirements. After that, once like these are the images, okay, these were taken by the rover. Now these images will be basically using the Raspberry Pi system. It will be uploaded to the Firebase. And from the Firebase, okay, the MATLAB base, an application has been designed. That application basically assess these images and then apply that trained deep learning neural network and help us to classify the date type and also the maturity stage. And based on these two, the classified outputs, the informed decision making is made by the system. How? This is a slide that actually explains this thing. So how like the deep learning neural network is working? So first of all the images that has been gathered, okay, we have a data set. That data set contains thousands of images of each type of 5 date types under different maturity stages. So after the labeling of the data, we split the data for the cross-validation into the training, validation, and testing data sets. So training is around 70%, validation is around 10%, and testing is around 20%. So it actually varies from the data types. And then after we apply the different augmentation techniques to enhance the quality of the data set, and then come the deep learning. Okay, we actually use different deep learning neural network, namely AlexNet, VGG16, we use ResNet 50, we use EfficientNet. Okay, so all these networks were basically tested. We use actually pre-trained neural networks. And after the testing and the fine-tuning of the network, we did the extensive hyperparameter testing. So once we have the trained neural networks, so that trained neural network will perform the classification task for both for the date type and also for the maturity stage. So as I mentioned earlier, we are actually using 5 different type of date types. So we can see here just some sample images. So this is a bunch of khalas. This is for the Barhi. This is Manif. This is Nabusef, and this is Sulaj. And also, for example, for the Barhi dates, we can see like each, even this one date has different maturity stages. For example, in immature stage, okay, the dates more like looks like a greenish, then it become kind of a yellowish, and then here we have yellowish and brownish, and in the tamar, like the more mature stage, okay, the color change like this one. And if we look at the Sulaj dates, we can say that in the immature, okay, it's like again more of greenish, yellowish, and here in the tamar we can see a clear difference that this is more brownish as compared to the tamar stage of the barhi. Number one. Number two, we can also see that as the date type is changing, for example, this has more of a kind of oval shape as compared to this one. And also we can see the difference, okay, between, okay, the shape of the dates between, for example, Nabut and Manif. But like this difference, for particularly, for example, if you talk about Manif and Nabut, this difference is hard to differentiate for an inexperienced farmer. So an experienced farmer can tell me by just looking at the date punch, okay, this is barhi. Then, for example, if we look at rutab stage of the barhi and we look at the rutab stage of the sulaj, okay, again, we need an experienced farmer to tell us the difference between that. That this is the rutab stage of barhi, this is the rutab stage of sulaj. I should harvest in this stage for this case. I should not harvest in this stage, for example, for the halal. So all these things in the real time using the conventional approaches are very hard. Okay, it requires experienced farmers, it's time consuming, a lot of time has to be done. And of course, human error factor is there. So that's why we are proposing our system that can, first of all, will classify. Just look at the bunch, will tell me, okay, this is a Barhi date bunch. This is the Naboot. So 5 different date types are classified. Then for each date, there are around 5 or 6 majority stages. So it will classify each majority stage also, so that we can make more better smart harvesting decision. This is just an information about the data set which we are using for the date type and the maturity stage classification. So we have around 11,036 images for the Barhi, around 730 images, okay, for the testing, for the Khalas, 720 for the Naboot. So overall we have 6,440 training images, which are 5 different date types. Similarly, around 10% are for the validation, and we have used good numbers, okay, for the testing also. For the data set division about the maturity stage, again, like see here, we have 6 different maturity stages. Okay, for the Barhi, again, for the immature stage, we have this much number of sample for the training, validation, and testing. So again, like Barhi has 6 maturity stages. So these are the, then Khalas had, so like this immature stage 703 images are of different date types. Halal, different date types. Okay. Halal with Rutab, different date types. Okay. It could be Barhi, it could be Khalas. So like each maturity stage has images of different 5 date types so that the system can be trained and learn the characteristics of each one. Now, as I said earlier, we have used different types of deep learning neural networks. Okay, so it is very important whenever we use a deep learning neural network or machine learning algorithms that we get a trained classifier that have a better accuracy. So for this, we actually did the extensive hyperparameter testings. So we changed the optimizer, we changed the mini batch size, number of epochs. So these are all called as hyperparameters. So we use ResNet 50, LXNet, VGG16, Efficient, and Inception version 3. LXNet and VG16 are basically the oldest CNN networks. ResNet 50, Efficient, and Inception are the state-of-the-art networks. The purpose of using this one just to compare that, which classifier could be better for this type of data set. So these are the just architectures of the LXNet and VGG16. So we can see that basically LXNet has a more deeper network, okay, compared to the like VGG16. We can see here. So like we have convolution layer. This is a typical network of a CNN model, that it has a convolution layer followed by a max pool layer. And then again, we have convolution, max pool. And at the end, we have basically the dense layers. And finally, at the end, we get the basically the classifying layers, classifying. And same thing basically happening in VGG16. So this slide shows basically the different classification trials for the date type as well as the maturity stages. So the first one is basically for the date using the LSNet. And we can see that using the SGDM optimizer with 200 epochs and 20,000 iterations, with a learning rate of 1 times 10 power minus 4, we get 100% validation accuracy. The test accuracy was 96.24, and it takes around 1075 minutes, which is like this time is quite high. And this was for the date type classification. Then talking about the maturity stages, the same LXNet basically produce an accuracy of 97.75%, okay, with the this setting. So like this comparison basically help us, okay, like which hyperparameters are basically better for the better accuracy. Same goes with for the ResNet. We perform the same thing for the both date type and maturity stages. Again, for the VGG16, okay, this table shows that. So like if you talk about the date type classification, from this table, we can say that So basically, more better test accuracies are obtained. For the date type is 97.33%. Also, like there is a small difference here. The difference is not big, but like these parameters could be the optimal one for this one. And also we can say that for the resonate 50, we are getting around 98.53%, which is basically better than this. And for the VG16, again, 98.89%. Okay, so like if we compare in absolute terms, so the VGG16 is basically performing better as compared to the LXNet and Resonate 50 here. But again, we can have a look that this difference is basically around 1%. It's not that big. So this can basically, VGG16 is the oldest network. Okay, it's a deeper one. So ResNet basically use the residual blocks. Okay, it's a state of the art current network. So it also gives us a good performance, but at the same time, okay, it takes basically more time. Okay, for the training, like 6,556 minutes. And AlexNet is taking just 1,021 minutes and giving us an accuracy of 97.3%. So again, this is taking around 5,000 minutes. So like 1% accuracy margin, okay, with a lot of training time, okay, like these are the trade-offs. If you want to go with the more state-of-the-art model, okay, maybe you can choose this one. So if we we actually did the analysis for the two different data sets, okay. Data set one has lesser number of images. Data set two has a different high number of images, which were basically improved using the different image augmentation techniques. And this table basically provides overall summary. Like if you talk about LXNet, for the date type, we are getting around 92%, 92.3% training accuracy, which is 16, 94%. Efficient net is around 98%. And inception is basically just tested for the maturity stage, give us 86.5%. So the overall comparison it gives us basically VGG16 is performing better, okay, as compared to the other five networks which have been tested. So now then we work on for further optimization of the VGG16 model. So for this, we basically the number of iterations was set to 2000. The mini batch size was 32. And this was the setting that basically help us. Okay, then we change the number of neurons of the last fully connected layer. Why we change to 5? Because we have 5 different date types. So like these layers, neurons can be adjusted as per the classification requirement. And this slide shows us the results. Okay, basically show the training and validation accuracy and losses. And we can say that here. So basically the training and the loss both are converging, which actually shows a good performance of the classifier. And this is the confusion matrix. Confusion matrix give us an idea that how accurately the classifier has predicted the true class. So for example, from this we can say that out of 11,200 times, so 1122 times, the Barkhi images was presented in front of the classifier and this has been classified as correct. 4 times, Khalas image has been classified as Barkhi. 3 times, Manif image has been classified as Barkhi. 5 times, Nabut has been classified as Barkhi. And 2 times, Soloj has been classified as Barkhi. But we can say that we have high accuracy. So around 98.77% precision and around 99.38% recall. So this showed very good accuracy of the classifier. Like there are very small cases where the classifier make the wrong prediction. And same thing can be noted. For example, for the Khalas, there was 100% precision. No false prediction by the classifier. And similarly, for example, if you talk about Manif, we have a good accuracy, 99.42% precision. For the Nabu Safe, 98.89%. For the Suloj, 98.35%. So if we talk about the overall, we are getting around 98.89%, which depict that the classifier is making very good prediction about the true classes. So like all 5 date types can be accurately classified using this trained network. Then same thing was done for the maturity stages. And here we can see that for when the network is exposed to the immature image of 1,531 immature images, it has been classified as true class. And only for the small number of classes, the network did the wrong prediction. So again, we can see here like 99.42% is the precision for the immature case. 98.55% for the khalal. Khalal will rutab pre-tamar and tamar. So overall, we get 98.17% precision for this case also, which actually depict very good performance of our this trained VGG network. Now, why this analysis is important? Why the maturity stage classification is important? The reason is, in the practical, as per the market needs, each date is basically harvested in different stages. For example, if you talk about barhi, and if it is in immature stage, for example, completely grain, it will not be harvested. But if it is in halal, this is also taken in market. If it is in halal with rutab, like these stages, like small greeny kind of more yellowish, okay, and small brownish part, and then more brownish, and then full brownish, then more ripeness, and this is the last stage that has highest ripeness, and this is basically the tamar. So barhi is basically can be harvested in all these four stages. So if we talk about khalas can only be harvested in tamar stage. It is never harvest, like it is not recommended to harvest this in these four stages. Then if you talk about manif, again this can be harvested from khalal till tamar. Nabut preferred is tamar stage. Sulaj preferred is khalal will rutab. So like all these analysis, like barhi, I can go with all these stages. I need to know. Like the farmer or the supervisor must know that, okay, what is the current stage? Should I go with the harvesting? Okay, are we going with the manual or whatever harvesting? That's a different story. But like all this informed decision making using this intelligent decision mechanism, okay, that can basically increase the accuracy of the harvesting. Okay, if I'm like the date is being manif is the date and it is being detected in one of these, so we don't need to go with the harvesting. So like if we want to do this manually, this is just a table for the one date type. So similarly, like we can have different kind of stages for the other type of dates. So it really requires an experienced person for this, which is becoming a problem in the worldwide. So to make it easier, I'm sorry, for the user, what we have did, we have developed a simple, very user-friendly interface. So after receiving the images from the Firebase, we can upload it here. We just select any image and our system will tell us using the deep learning neural network that what is the date type, barhi, sulaj, what is the maturity stage, and what is the harvesting decision for this. Should I go with the harvesting or not? And what is the location? And when was basically this image was taken? Like report did the tour today, this is the result. Report did the tour tomorrow, this is the result. Okay, all this can be displayed. So like if you want to like check image by image, you can do that. Otherwise, you just click print summary report. So for all the images which has been taken during the one tour of the robot, for example, robot visited, let's say 50 trees and taken the images. So when we press this print summary report, so the analysis will be done for all 50 images. A table will be made, and that can be basically sent to the supervisors or the farmers or the main managers. Like this is the status for today. And then the rover can go, for example, in the morning, afternoon, night, or day, weekly, whatever mechanism. Okay. So such summary reports can be generated. So we have a clear comparison. Okay. Like this is the stage for today. This is for tomorrow. And better decision making can be made. So this is just one output result. So this is one image. And the system has classified, predicted it as a barhi. This is the immature stage, and that's why we should not harvest it. Okay, this is the location. Like basically this image, the image name basically contains the information about the date and time and about the barcode of the tree. So another very important thing of our development method is usually in the real time. Okay, the image can be taken under different environmental conditions. For example, if you're taking an image in the morning, the background could be different. And if you're taking, for example, afternoon or the noon time, we could experience higher sunlight. Okay, so that can give us basically a different kind of image. So, but still, like our system can predict it. Okay, if you take an image, even different environmental conditions. Now, sometimes what happen? We have the date bunch, which are basically covered with the bags just to protect them when they basically reach the harvesting stage. So we can see that even like if you are just doing the walk in a park, we can see that. So with when the cover when that is covered with the bag, so for the conventional system, actually it becomes more difficult. But our system basically can predict even in that cases also that if there is a bag, no bag, different environmental condition, different angle, okay, no problem, because we have basically prepared our data set to accommodate all these factors in. And when we trained our model based on all this, then our performance is very good. So this is an example of the summary report that can be generated. For example, out of all analyzed images, okay, there was 35 images of Manif that were basically in immature stage. There was 40 images of Naboth that was in immature stage. There was around 10% images of Suraj that was in Khalal. Around 20% was in Khalal. So Naboth safe. 65% of Manifi was in Khalal. So like all the percentages of all the analyzed images can be shown here. That 100% of the Barhi images that were analyzed basically were in Khalal. So that's why we should not harvest that. So this summary report and also like a second summary report, okay, it can be given like for the Barhi, we have analyzed like total 31% images, and out of them only 20% are basically in the harvesting decision state. For the Khalal, from the analyzed, okay, we have like these all percentages. For example, for the Manifi, we analyze 18%, and out of those, there is no image that is basically in the harvesting decision. And this is another very good summary report that basically give us analysis for images and images. Like this first images that have been analyzed, date type is Barhi, maturity state is this, and this is the decision making. So like even if you want to go like you have taken multiple images of one tree because it could have multiple bunches. So like still like the information about the all the information can be extracted from the given system. And all these summary reports, this can be sent, okay, to the farmer using the email. Okay, just when we press the print summary report and send, all these three summary reports which are generated, that will be sent to the farmer on his email. So this is just a simple demo for experimental system. So you can see here, this is the actual farm. The robot is moving. So the first QR code is red, move on, it reaches to the tree. So that's the tree. Okay, this is tree one. And now the top camera is taking the image of the bunch. And then it keep moving on. Okay, so when it say the finish QR code, it stop. So we could have like multiple barcodes and it could take multiple images. And once like the images are taken, the round is finished, all the data will be transferred using the Firebase. And here we can see that these are the received images. Okay, from the like the Raspberry Pi will take and all the will transfer using the Firebase. And here it is our user interface, and we can see that basically just like for example, we just click on upload, we can get the basically image. We just select the select image. And as soon as the image is selected instantaneously, our system will display the results. Like this is the Barhi, this is immature, this is the harvesting condition and the details. And further on, when we just click on the print summary send email, all the images that will be progress. For example, here we have only one images. So this is Barhi 100%. But if we have multiple images, similar kind of reports can be generated. And the system, okay, will send those reports to the main supervisor of the system. So in conclusion, what we have done, we have successfully implemented an intelligent deep transfer learning based autonomous system that can help us to capture the date bunches and as well as help us to sustainably classify them using five different date types as well as 5 to 6 different maturity stages. We use our autonomous system basically based on QR codes for the date localization. We use the advanced KNG lane detection techniques. YOLO version 8 was used for the localization and image capturing. And then we analyze 5 different deep neural networks, and out of them, we determined that VGG16 is performing better overall for this data set. So the advantages are, like, if we are going to deploy, we are working on the developing more advanced systems for this. So we can enhance the speed and efficiency of the data production. For example, we are using the Raspberry Pi in the data processing unit here. That can be replaced with the more AI enabled, most advanced processing unit, for example, just a Nano, that can help us to speed up the processing. We can use the real-time data so that we can display the harvesting at the same time, harvesting decision. For example, now the data are transferred to the Firebase, and then the decision is made. So that can be done in real time, okay, with the more advanced processing unit. And the overall, okay, the implementation of this system will help us to minimize the environmental impact, because we are basically helping to minimize the deforestation and contributing in the biodiversity that eventually help us to minimize the carbon emissions. So these are some of the references. Okay, that's all from my side today. I'm open for any question and answers. Thank you so much for your time. So Ms. Ivy, I'm open to any question and answers if we have. Okay, I can see the one question from the Anas. Thank you so much, Anas, for your very good question. Actually, right now we haven't used any VLM model or transformers. Right now we are just using the YOLO version 8 just to capture the data images and their localization. But we are working on more advanced models, okay, and to improve the further efficiency of the our autonomous systems. So currently, we don't have any open position, uh, but keep in touch with us, and we will let you know whenever we have any such open position. Thank you so much. So do we have any other question from any of the participants? All right. Thank you so much once again for all the participants for joining this workshop. I hope the discussion could be fruitful. Please feel free to reach to me for any further question if you have. Thank you so much. Thank you so much, Ms. Avi, for your assistance.
Thank you, Doctor.